All right, here we go. The next lesson, 16.4, and we're going to be covering peptides, the different types of peptides there are. And apologize, it's been a little slow start getting ready. I sort of changed up my routine, made it a little bit more efficient than maybe the first couple videos you've seen. And great, I think I'm ready to rock and roll now with a lot of videos, so I'm going to be giving a bunch. Probably finishing this chapter out by either this weekend or the beginning of next week, so that it's all there and ready for you to start watching at your own pace and at your own time. And hopefully you guys are also reading the textbook. If you're doing that alone, you could honestly just go ahead of me. And all right, but let's just switch over to the, you don't want that screen. Okay. So we got proteins version 2. I just want to, this is the PDF I uploaded pretty recently, you may have noticed, on Google Classroom, and it's so I can access it from my desktop here. You probably don't care about those details, but anyways, it allows me to open it and actually use my mouse as a pointer. So I know when I say, let's look at this carbon and that nitrogen, and you don't know what I'm talking about. So it helps when I can point. So I can say, hey, we're looking at this carbon or this carbon, and rather than saying carbon number 1 and carbon number 2, that can be a little difficult. Let's do a quick recap what we've done so far. Not from that screen, but from the introduction. Remember, we introduced the structure of amino acid, and we said that a protein is essentially a bunch of amino acids. It's a chain of amino acids when you join them together through amide bonds. And then we also went into great depth about amino acid structure. We did talk about what proteins are used for, which is very versatile, because all DNA does, and I'm going over this with my biology class right now, protein synthesis. All DNA does is make proteins. Protein synthesis, that's what it is used to do. DNA is the code for what proteins will make. So if all you start out as is one cell with some DNA, it better have all the information to make you, make all the proteins that can make you, and sure enough it does. Some of them are hormones that will control reactions. Some of them are structure, like for your hair and skin and nails, and they make up tissues. Some of them transport oxygen. They all have different purposes, so that's important, because that's what DNA does, is code for making proteins. So proteins are a very flexible molecule in terms of what they can do, and what they can do is based on their shape, which is we'll get to at the end of the chapter. But one thing to note first is what the structure of proteins is. Like, how do you get a protein? Well, it's basically a chain, like we said, of amino acids. And so here you go. Here's your amino acid structure. I threw this slide in. I think it did a better job than what the book did. You got your central carbon here, which we call the alpha carbon, and everything surrounds it. Remember, it can bond to 4 things. Carbon can bond to 4 things. And in the case of amino acids, it's always going to bond to a hydrogen. You're always going to have just one of the things is always going to be a hydrogen. Very simple, very simple. The other 3 groups are well, let me say this. It's always going to bond to a hydrogen. It's always going to bond to an amino group, which is NH2. And it's always going to bond to a carboxyl group, which they really should have labeled as carboxylic acid. And that's why we call it an amino acid, because it has an amino group and a carboxylic acid group. This is a carboxylic acid functional group. And then this R group, that's the 4th thing here. The R group is the only thing that varies, and that depends. So it could actually even just be a hydrogen, just like that. That's the most simple amino acid, but usually you're going to have a branch chain or a long chain of carbons, and you could even have ring structures, and depends. Here's just another picture showing that. And we looked into how to make a peptide bond, okay, by joining different amino acids together. And you hopefully have seen that lecture and noticed that we did lose a water molecule and that we formed a peptide bond here. Those are details in the other lecture. Sorry. And yeah, so that's what we've covered so far. We looked at the stereochemistry also of amino acids, because those 4 things are all branching out equally distanced from each other, and so there is no up, top, bottom, or side, or left or right. And so, but one thing you can do is you can write these, what do you call them, Fisher projections, like we did for the sugars, the monosaccharides, and you can lay them out like this so that you have the carboxylic acid at the top, the methyl group at the bottom, and then, well, no, not methyl group at the bottom, I'm sorry, the side chain at the bottom. In this case, for alanine, it has just a methyl group as a side chain, but whatever your side chain is, it goes on the bottom. And then if the amino group's on the left, it's an L isomer. If the amino group is on the right, it's a D isomer. We talked about that. And then here's some awesome chart that has the 20 amino acids. It has their abbreviations, 1-letter abbreviations, the 3-letter abbreviations, their name and their structure, and it's even organized so that you have all of your neutral amino acids. And on the next page, you have a couple of the acidic and 3 of the basic. And if you forget what that is, it has to do with the side chain, adding in either an acidic or basic component. And then we talked about the acid-base behavior. We talked about what happens when amino acids are placed in acids or placed in bases. They'll do different things. Here's just another chart of amino acid bond line structures. I like that, but it was in Spanish too. So, and here's another one also. It's kind of neat. Showing you even the molecular weights. And so, anyways, all that stuff's on Google if you ever want to find your own stuff. Cool. So, what happens? Yeah, when you put it in an acid, what happens when you put it in a base? You're going to see actually going to get a reaction, and it's going to change the way the amino acid looks. You're just going to change its structure. Or notice the homework calls them species. It can have either A species, a B species, or a C species. A species is what you start out with, and so it's either going to be a B species or a C species, but whatever. And so you can see again when you add it in different pHs, the amino acid will change its structure, whether it's in an acidic pH like 2 or a basic structure like 11. You'll see that the proton will, anyways, yeah, just go watch that lecture. I don't want to go on a tangent. I want to start 16.4 right now, which is about peptides. And so let me get back to here. I don't really have a learning objective, but basically we're going to identify peptides. We're going to be able to look at the structure of peptides and identify key components to peptides and classify them also. We're going to classify them. And so let's get back to the lecture. Ooh, the tunnel of doom. You like that when I do that? Because I'm sharing my screen, and right now my screen is showing my software I use. All right. Okay, so here we go. When an amino acids are joined together, they're going to form peptides. They're going to form peptides, which are eventually going to be your protein. I know we're doing a lot of talk about polypeptides and amino acids, but that's because they make up a protein. That's the primary structure of a protein. In the beginning, you essentially just have a bunch of amino acids that form peptides, and those peptides get joined together by peptide bonds, and then you can do some work with twisting and folding, and actually all that twisting and folding is done by the interactions with the different peptides. So there's attractions or repulsions by each other. The peptides will either be attracted to each other or repulsed, and so that'll make the chain of amino acids, the polypeptides. It'll make it kind of move and twist and take shape. And that's how proteins will operate, is by like a lock and key mechanism, and based on the shape of the key or based on the shape of the lock and so on, proteins will do different things. But so we basically just have two different peptides here. We have a dipeptide or a tripeptide. And so you guessed it, those prefixes di mean you're either going to have two peptides, or the prefix tri means you're going to have three peptides joined together. All right. Proteins, though, have many amino acids joined together in long linear chains, but the term protein is usually reserved for polymers of more than 40 amino acids. So it's going to be, like I said, a lot, like more than 40, and actually considerably even more than that on some proteins. The amide bonds in peptides and proteins are called peptide bonds. So if you scrolled back a couple slides in 16.2 or 3 or whatever, they were calling this carbon-nitrogen bond here, they were calling that an amide bond. But you can also call it a peptide bond. So it's got just two different names there. Those are interchangeable terms. Amide bond is this carbon-nitrogen bond. That's that carbon-nitrogen bond is the amide bond. But in this case, since that carbon's on a carboxylic acid of an amino acid and it's joining another amino acid to form a peptide, we can call it a peptide bond. Peptide bond is like a specific amide bond. You can have amide bonds all across the board in different contexts, but in this case, since we're joining peptides, that amide bond is a peptide bond. And the individual amino acids, they're sometimes called amino acid residues. We call them residues. Okay. All right. So to form a dipeptide, jog your memory here. I think this was covered in another picture early on that I provided. The amino group is going to join with the carboxylic acid group of the other amino acid. So the amino group of one amino acid will connect with the carboxylic acid of the other amino group or amino acid. All right. So how does that happen? How does that happen? What is the mechanisms behind that? Because it's obviously going to involve a chemical reaction. Okay. And by the way, that chemical reaction is going to produce water. So this is going to be like a dehydration reaction, we call it. A lot of reactions in the body are going to either be like hydrolysis or dehydration. And so in this case, let's see what happens. And this is pretty easy to remember since an amino acid is all about the carboxylic acid and the amino group, then it's pretty easy to remember that when you join them, that you join them by these two main groups. Like these are the main highlight groups. I'll take that back. The side chain of an amino acid is really what makes it unique. That's kind of its name, its dog tag, because on every amino acid you're going to have a carboxylic acid and an amino group. Carboxylic acid and amino group. The side chain is what makes it different. In this case, we're dealing with alanine and serine, so you can see how the side chains are a little bit different there. And so those are very important too. But it is easy to remember that the carboxylic acid and the amino group are what joins, okay? And what happens is that the hydrogen of the amino group, the hydrogen of an amino group will come together with the oxygen and hydrogen of the carboxylic acid. And what you'll get is this amide bond, and you'll be losing water. And so actually, let me say that again. I said that wrong. Excuse me. You're going to have H2O as the byproduct. So we need two hydrogens and two oxygens. I said only one hydrogen comes from the amino group, but it's two hydrogens that come from the amino group. And it's not the OH from here, it's actually just the O. Because remember that H, that hydrogen actually went over here to this amino group. This used to be NH2, and this used to be OH. But that H, when these are by themselves, and not in, just say a neutral pH solution, what happens is the acidic part of the hydrogen will come over here and protonate that's what we call it, protonate the amine group. And so you actually have a positive charge and a negative charge. Remember the Zwitter ion? So when you form this bond, you're actually borrowing these two hydrogens and borrowing this oxygen here. You're borrowing these two hydrogens and this oxygen. And what that's going to do is free up this carbon and free up that nitrogen to bond to each other. And so that carbon-nitrogen bond right there is going to be your amide bond, which we call a peptide bond, remember? But in just its general form is called an amide bond. So there you go. The amino acid with the free amino group, that's going to be this one here. This is important. This stuff in blue or shaded. Remember, we always want to jot these down in our notes, or just be able to, when you're studying back in the textbook, always read these bold-faced things. They're very important information. And so we have two types of amino acids, N types and C types, or N-terminal and C-terminal, and it's important in the classification of amino acids. And so we want to start with this groundwork first. So check it out. The amino acid with the free NH3 group, that's going to be this one here. Excuse me. We're going to make this bond, and then once you make your peptide, you see how only one of these amino acids has a free NH3 group, a free amino group? And that's because the other one was used in the reaction, remember? So this one's not really free. It's tied up in the reaction. It's now participating in this amide bond. So the one with the free amino group is this one here, this first one, this alanine on the left, right? So this is going to be the N-terminal amino acid. And the way we get that name is, you see how it's on the terminal end of the peptide? Like this is the beginning, but it's still the end, right? It's at a terminal end. And so this would be the N-terminal. And the N is standing for the nitrogen. So this is the N-terminal amino acid. Now, you guessed it, the other one's true. You see how the carboxylic acid is free on the serine even after you connect these two? So even after you connect these two and you have your peptide, then the carboxylic acid, it's on the terminal end of this long peptide here. Well, it's not that long, but this peptide here has got a lot going on in the middle, but at the end, here's a terminal end, and this is the C-terminal end. The C stands for that carbon there that's in the carboxylic acid. And so that would be serine, that is the C-terminal amino acid in this case. And so by convention, the N-terminal amino acid is always written at the left end of the chain, and the C-terminal amino acid is at the right. So when you draw a peptide, always draw it with the N-terminal on the left and the C-terminal on the right. All right. So always draw them that way. And the way they're named is according to that too. So peptides are named as derivatives, basically, of the C-terminal amino acid. Derivatives of the C-terminal. So in this case, we have a serine, basically. But what type of serine? Well, we have an alanyl serine. Alanyl serine. That YL is a suffix that you add to the N-terminal amino acid. You basically drop the ene, add the YL for the derivative. So let's back up. Peptides are named as derivatives of the C-terminal. What does derivative mean? Derivative is like a type, like you have different types. You have different species, or you have different variations, you could say. And that's a term used in calculus, right? So there's a lot of different possibilities of the C-terminal amino acid. So if you wanted to really call this thing for what it is, it's kind of like a first name and a last name. Let's say that. That's a perfect analogy. I just thought of that. Nice. Proud of myself. The last name for this amino acid is serine. This is a serine. Now, which serine is it? Is it the oldest, the youngest, the firstborn, the secondborn? Which is it? Dad? Because there's many different family members that have the same last name, even mom. But the first name is more indicative of what type of derivative of that amino acid. And so in this case, since we have an alanine, we drop the ene on the alanine and put alanyl. So it's an alanyl serine. And you can abbreviate that by just putting ALA-SER. Remember those 3-letter abbreviations, they're up here in this chart. Oops. The one that's in Spanish here. It's even in your book too. Your book, the book has that page of all the amino acids, and the abbreviations are there. All right. Now, here's a sample problem. Let's do this one. Label the N-terminal and the C-terminal. Label the N-terminal and C-terminal in the following tripeptide and identify the individual amino acids. What is the name of the tripeptide? All right, cool. So analyze this problem. The N-terminal of the amino acid, remember, is going to have that NH3 group exposed, and it's going to be on the terminal end. So here you go. Always look to the edges of your long peptide and you'll find your stuff you're looking for. Right now we're looking for that NH3, and there it is. Well, what amino acid is it that has this as a side chain? CH2, CH, and then CH3 to the 2, or having two of those. That would be, well, I'm not going to scroll up because it's kind of obnoxious, so I'm just going to go, because the answer is already here. We'll go to the solutions here. But before we do that, you also want to make sure to continue to analyze this problem. You want to look for the one that has the exposed C-terminal end, right? That's going to be this amino acid here. See how it has the C-terminal end over here? And it's always going to be the case. You're always going to have that amino on the left and then the carboxylic acid on the right. Okay, they're going to be opposite to each other. And in this case, this is the amino acid that has this as a side chain, right? That has this benzene alcohol connected to that carbon. So there you go. Wait, was that it? Where's the answer? I guess that's it. There's got to be a solution. 546, 550, 549, 548. I'm missing a page, aren't I? I'm missing page 547. Oops. But you get the point. You basically just got to go to that chart and figure out which amino acid is this, which amino acid is this. And then to name the tripeptide, you're going to have those abbreviations, right? Dash, dash. But what I'm curious about is how did they do the tripeptide name? Because they added the eel. They added the eel to the first name. But you know how sometimes you can have a middle name? That's what you essentially be having in this case, is you'd be having something with a middle name. I know. Going to proteins version 1. Limited connectivity. I know. I got on my iPad here. I'll go back to where we were. Oh wait, I can't do that. I'm gonna go back to where we were there, and then in the background here I'm gonna look at my iPad here and see what the answer is. Well, there's a lot going on page 547. I'll make sure to get that to you. There's a lot of problems there. 16.8, 16.9, 16.10. Those I'm giving you to do anyway. I'm not doing those in the lecture, but in the solution, there's a really cool picture there. I wish I could. Oh, I know what I can do. Here. And then I'll get you guys this picture soon. As soon as I'm done with this video, I'm uploading the picture for you guys. Let me go to camera 3 here. Let me just verify that you guys are seeing that. Yeah. But it may be blurry on your end. That's why I'm another reason I'm using my desktop instead of this iPad screen mirror. But the solution here is yep, you're going to add YL to both the first name and the second name. That's what I thought. So it's going to be something eel, and then finally the last name, which you don't change. And in this case, that the C-terminal amino acid, which is always going to give you your last name, was tyrosine. The N-terminal amino acid was leucine. Now that alanine doesn't really have anything exposed, is it? It's just the middle name. It's kind of like, who cares, right? Who cares about your middle name? We don't even know each other's middle name usually. And so this is leucine, alanine, and tyrosine connected to each other. but leucine is the first name, alanine is the middle name, and tyrosine is the last name. And so remember what to do with the first name and middle name. We just said it, is you got to add that YL. And so you would say leucyl alanyl tyrosine. All right, leucyl alanyl tyrosine. And they just write it out as one long word there. You can see, well, you can't see on my mouse on the iPad, so sorry. So there you go. And then if you were to label it, what they do here is they just take the name, they just write N-terminal amino acid, and they draw an arrow pointing to it. And then they put C-terminal amino acid, and they draw an arrow pointing to the C-terminal amino acid. Okay, I don't see anything else there that I probably need to mention, so because of that, I think I'm ready to end this video and then have you guys work on the problems associated with that. Stay tuned for the next one, which is going to be about, actually hold on real quick, just real quick. Let's look at this sample problem because it's actually there. I actually have this page here. It says locate the peptide bond and the dipeptide shown in the ball and stick model and identify the amino acids that form the dipeptide. Name the dipeptide using the 3-letter abbreviations for the amino acids. And so hopefully you're able to see all that bond line drawing stuff in this ball and stick model. Remember that carbons are black, the oxygens are red, nitrogens are blue, and hydrogens are white, and yellow is sulfur. And so you have to be able to look at this structure and correlate it to these type of structures. And that's actually part of the analysis of the problem. What you're going to want to do is convert that to a bond line drawing to make it easy for yourself. All right, the solution is to draw one of these and do that. But you can actually quickly identify that peptide bond, and it's pretty obvious. Remember, it's carbon-nitrogen. It's a carbon-nitrogen bond. And so you can see that this first amino acid here has that exposed amino group. So there's your first name. The second amino acid is this guy here that already used up his amino group to make that peptide bond, but his carboxylic acid is free. And so that's your last name. And so basically you're looking for the side chains, remember? The side chain for the first amino acid looks like it's just a methyl group, pretty simple one. The side chain for the second amino acid is this CH2 and then SH, right, with the sulfur there, and that would be cysteine. So we have alanine cysteine, but remember we don't say it that way, we say alanyl cysteine, but they asked you to do the 3-letter abbreviation, so it's just ALA-CYS, right? And if you wanted to label it, you would just write the word peptide bond, point to it, draw an arrow. You could draw an arrow there. So that's how you would label that. So there you go. There's one of your own to do. Problem 16.11 with a ball and stick model. All right. So now I'm curious as to what is going on my OBS. I just noticed both lights were red. So I'm sitting here showing you stuff and you're not seeing any of that. Oh, what happened? Oof. Just in case you didn't catch that. If you did, just go ahead and stop the video, you're done. But if you didn't catch that for whatever reason, there was an error, I don't want to stop a recording and then re-record. Here's sample problem 16.4. It says locate the peptide bond in the dipeptide shown in the ball and stick model. Kind of the tricky part of this is that you have a ball and stick model. And identify the amino acids that form the dipeptide. Name the dipeptide using the 3-letter abbreviations for the amino acids. Whew, they're asking us to do a lot, aren't they? The first thing they want to do is, want us to do is to locate that peptide bond. Well, that's pretty obvious. It's always just going to be that carbon-nitrogen bond that you see here in the middle, joining two amino acids. And if you remember, the carbon-nitrogen bond comes from the carbon that's in the carboxylic acid of one amino acid and the nitrogen that's in the amino group of the other amino acid. All right, So if that's happening, if we're using up those functional groups to make this bond, the other functional groups are exposed. And so for the first amino acid, that NH3, the amino group, is exposed. That's the first name of the amino acid. The other amino acid has the carboxylic acid exposed, and that's going to be the last name of the amino acid. Just like you have amino acid. Amino comes before acid, right? So acid is the last name. Amino is the first name. And so that's what they want us to do, is to name the dipeptide. They also want us to identify the amino acids that form the dipeptide. They want us to do that first, and you would have to do that first if you wanted to name this dipeptide. You got to know what amino acid you're dealing with. And so how do you know that? Well, it's all about the side chains, remember? Every amino acid has carboxylic acid, it has an amino group, and it has a hydrogen, but what else does it have? That's the side chain, and that would be, for this amino acid, it'd be this methyl group here. And then for this amino acid, after you consider the amino group here that's participating in this bond, the carboxylic acid over here, the lone hydrogen there, then you have CH2SH, right? And so here's a better drawing of that down here. If you convert these ball and stick models to drawings like this, it should be a little easier for you. And so CH2 with bonded to an SH, a sulfur and a hydrogen, that would be cysteine. So that's going to be our last name. And the simplest amino acid is this one here, alanine. Actually, that's not the simplest. The simplest is if you just had a hydrogen as a side group or side chain. But methyl group's pretty simple too. So that would be alanine cysteine, or alanyl cysteine is the way you'd say it. But they just wanted the 3-letter abbreviation, so it's just ALA-CYS. Okay, and then here's your problem of your own, 16.11. All right, this page is in your slides. So now I'm going to stop this video and go upload page 547 is the only page I accidentally forgot to upload. So page 547 is just going to be an independent page that I add. Okay, thanks, bye.